Hello guys, KNOCKCAT this side. So today we are solving yet another problem on GFG, and that is sum of all substrings of a number. So it says that we are given an integer s represented as a string. Our task is to get the sum of all possible substrings of this string, and if the answer will be large, we have to return it modulo of 199 plus 7. And it says that string may have leading zeros. So in this question, it clearly says that we need to find sum of all possible substrings. So let's come to the whiteboard. So I have taken the very first example and it is 1, 2, 3, 4. So the number of possible substrings it has displayed or written for it as 1, 2, 3, 4. So let me show you that how these possible substrings actually came. So if I have 1, 2, 3, 4, so first substring would be 1. 1, 2 is a one possible substring. Okay. Then 1, 2, 3 is one substring. Then 1, 2, 3, 4 is one substring. Then 2. Starting from 2, one substring is 2. Another substring can be 23. Then another can be 234. Starting from 3, one substring can be 3 and another can be 34. And starting from 4, the only substring we can have is actually 4. So these are the number of possible substrings for this given example. Now, if you can see 1, 2, 3, and 4, these are actually mentioned here. Then 1, 2, 1, 2, 2, 3, and 3, 4, all length 2 substrings. 1, 2, 3, 2, 3, 4, all length 3 substrings, and 1, 2, 3, 4, length 4 substrings. So now we need to find sum of them. So if you sum all of these, you will actually find 1, 2, 3, 4 is nothing but 4 plus 3, 7 plus 2, 9 plus 1, 10. So this gives you 10. Similarly, 1, 2, 3, 4, 1, 2, 3, 12 plus 1, its sum would be like 13. 13 plus 123 plus 1234. So it gave us like around 13, 1370. And then next is 2 plus 23, 25, and 25 plus 234. It would be 259. And this 3 plus 34, it is 37, and this is 4. And if I sum all these, its sum would be like sum here only 130, 259, 37, 10, and 4. 7, 4, 11, 9, 1, 10. So it goes like this 7, 5, 12, 13, 16, 17, 1, 3, 4, 5, 6, and 1. We are getting 1670, and this is the expected output. So somehow we need to find the sum of all possible substrings. So the naive approach would be we get all the substrings and iterate on that to find the possible sum. So that is, this can be done like I go to 1. Okay, I am iterating like if I get 1. So next time when I have come at 2, the string I would be forming would be 1, 2. The next time the string would be forming 1, 2, 3. And the next time the string would be forming 1, 2, 3, 4. Isn't it? So like if we are given with this sort of strings, can I 1 can be written as 1 only. Can I write 12 as nothing but 1 into 10 plus 1 into 10 plus 2? Yes, this we can write. For 1 to 3, we can actually write it as 100 into 1 plus 1 into 10 plus 3. Can we write it like this? Or like 2 into 10, 2 into 10, 2 into 10 plus 3. This will give us 100, this will give us 20, and this will give us 3. And similarly, for 1, 2, 3, 4, can we write this as 1 into 1000? Yes, 1 into 1000 plus 2 into 100 plus 3 into 10 plus 4. We can write this in this form. So if you can observe here, this is actually the same that we are writing here, like, 2 into 10. Earlier we already have 2 into 10 and 100 into 1 here. And here we have 1 into 1000 and 2 into 100. So although we are just multiplying into 10, like in here also, here we have 2 and here we have 1 into 10. But the next time we have 100 and 2 into 10. That means this substring is just multiplying by 10. So I can iterate from I to j in a fashion like from iterating from I to j, and let's say at some point I'm starting my num with 0, and for the further steps from j to n, the number I can generate would be as num into 10 plus my current character. That would be, you can say, s of I minus 0, because this will give us the digit. So if I do in this manner, let's have a dry run of this. So this is the, okay, I'm taking this only. So this, let's take this as something 1, 2, 3, 4. So here num into 10, and num is initially 0. So 0 into 10 is nothing but 0 plus 1. So we form 1. And next time, and this we will assign this to num also. Okay, we will assign this to num also. So now my num will become 1. Next time my num would be 1. So 1 into 10 would be 10 plus this 2. So do we form 2? Sorry, do we form 12? Yes, we can. Next time my num would be 12. So if I do 12 into 10 plus 3, do we get 123? Yes, we can. And similarly, next time my num would be 123. So if I again do into 10, which will make it 1230 plus 4, and which will give me 1234. So in this fashion, I would able to generate all the substring from 1 to 4. Next time, so the string that will generate in this fashion would be 2, then 2, 3, and 2, 3, 4. So similarly, if we would be able to generate all these substrings in this fashion. So this would be the brute force approach that will give us a time complexity of order of n square and a constant space. So if I show you the code for this approach, I would at the end I will also attach in the description. So the code for this approach is actually this. We just put long num equals to 0, and at each step I am calculating num as num into 10 plus s of j minus 0. And we have to do modulo because the question says that you need to return the answer as modulo. So what if I don't do the modulo, then what the problem is, because we have 1e5 digits, 1e5, and 1e5 means 1e5 zeros, and we can only hold up to 1e18 in long. So we have to do a modulo so that it don't overflow. Okay. And at the end result also we put as, we add in our result as the modulo of that given sum. So this will give us the answer, and this is the naive brute force approach. So now, can we do better? Now let's see how can we solve this problem in an optimized way. So can I say 1, 2, 3, 4? Can I write the strings that are ending at my s of 0? Can I write the number of possible strings whose last character is s of 0? That is 1. So the number of string possible would be only 1, because keeping 1 at last, the only string is possible is 1. Now I came to the second index, 2. Can I write the number of strings possible whose last character is s of I? That means the number of strings can be formed whose last character is s of I, and s of I is 2 here. So let's fixing 2 at the end. So 2 is possible and one string is 12. Now, can I say number of strings possible whose last character is 3? Okay, saying 3 would not be right, because we can have multiple 3s in other test cases. So I'm saying number of substrings that are possible whose last character is s of I, and s of I is actually 0, 1, 2 second index. So fixing 3. So 3 can be formed, then we can form 2, 3, and then we can form 1, 2, 3. Now, similarly, number of substrings possible whose last character is s of 3, because s of 0 base indexing, s of 3 would be 4. So we can form 4, we can form 34, we can form 234, and we can form 1, 2, 3, and 4. So now look at these. This would be fixing the 0th character at the end. This is when I fix 2, that is a 1th index. This is when I fix the third character at the end, that is the second index, and this is when I fix the fourth character, and that was the third index. Now, if I say, look, that we need to find sum of all these, right? And we need to find sum of all these strings. So let's say if I have to find the sum of this, fixing my S of 3 in which was actually, let's say, we can say dp of 3, in which the ith index was fixed. So this 3th index is fixed, would be the sum of all these. So it would be 4 plus 34 plus 234 plus 1, 2, 3, and 4. Can I write this 4 as 4 into 1 plus this 34 as 30 into 10? Sorry, 30 into 1. Or sorry, more formally, we can write this as 3 into 10 plus 4. Similarly, this would be 230 into 10 plus 4. And similarly, this 123 would be 123 into 10 plus 4. Can we write this as this? And now we can see 4 is common. So can I put 4 as a part? And now these all numbers would be nothing but these all would be nothing but 3 into 10, 3 into 10 plus my 230 into 10, or like 230, 3 into 10, or we can say 20, 230, 230, or this would be my 123. So this will be 1230, and this is 30 only. And so we have kept 4, and since I kept 4 apart, and 4 is 4 times, this is actually, I kept 4, 4, 4 apart, and this 4 is 4 times, so 4 comma 4. Now can you see this? What is actually this? If you can observe, this is nothing 3 into 10. Now if I take 10 common from it, then it would be on multiplication, then it would be 3 inside, then it would be 3 inside, this would be 23 inside, and this would be 123 inside. So this 3 plus 23 plus 23 is nothing but my dp of 2. Let's see here, 3, 23, 123. 3, 23, 123. This is nothing but my dp of 2, which is multiplied by 10. Which is multiplied by 10. So can we able to deduce the formula here? The formula is, like, can we able to deduce the formula? 4 was the character at that we fixed. 4 was the character that we fixed. And this 4 was the number of times it would came. So that if you have to count the number of times, here it came 4, here 3 came I times, like I plus 1 times. Here when we fixed 1, 1 was actually coming as 2 times. Here when we fixed 1, it was actually coming at 0 index, so 0 plus 1 times, that is 1 times. So can we actually deduce this is nothing but s of I 4. That 4 outside, it's nothing but my s of I minus 0. This will actually give me 4 into I plus 1 because this I have to keep I plus 1 time 4, which is at index 3, and I had to fix 4 times. So into I plus 1 into, sorry, not into, and now plus this is nothing plus my dp of 2. So dp of 3 would be nothing but this s of I, like 4 into 4, that is s of I, the character I have, into I plus 1 plus my dp of 2. So if I have dp of 2 here, if I already know dp of 2, I would have used dp of 2. Similarly, dp of 2, can you get dp of 2 from dp of 1? Now look how you can get dp of. So this would be, you can see 3. So 3 is at, so 3 would be common here. So we have kept 3 outside, and plus, if you see, this is nothing. Now it was left was 20, and plus 120 was left here. And you can clearly see 2, 12. This is nothing but 10 into my dp of 1. So in this manner, I get to, if I know the prior state, can I calculate the next state using this formula? And this is not formula, this is pure observation. We kept 4 outside, so that direct calculator, how many times is that 4? And plus my previous into 10. Okay, yes. plus my previous dp of 2 into 10, because it was a multiple of 10 here. When we kept 10 outside, then we get this state. Then we get exact the prior state. So our formula, our formula actually turned out to be s of I. Let me try to write it clearly. Minus 0. This will give us number into the number of times we have fixed, which is equivalent to I plus 1, plus 10 into our dp of I minus 1. So this is the formula that will help us calculate the number of substring at dp of 3. And our definition for dp, let me write it, because knowing the definition of dp is very important. Our dp of I, let me write here, our dp of I is equals to, what our dp of I means. Dp of I means number of, or like not number, sum of substrings till index I, till index I, whose last character is s of I, s of I. Sum of substrings till index I, sum of substrings till index I, whose last character is s of I. S of I, the last character was fixed. This is our dp. Our dp of I is storing the sum of substrings till index I, whose last character is s of I. No one will actually tell you what our dp of I means. They will form table, they will tell you that dp is actually stored in the previous state, but what's the meaning of dp? This dp of I is sum of substrings till index I, whose last character is s of I. And we clearly see here s of I character means when we are fixing this end character. I fix 1 here, I fix 2 here, I fix 3 here. So this dp of I 2 was actually giving when I was fixing till 2, till index 2, when I was fixing my second character at the end. So this is our dp of I. And in this manner we can actually formulate this. Now the question revolves, can do we need this now? This can be solved using dp. And since we have to take care of modulo, we will do the modulo, and that I show you in the code itself. Now, do we need the dp state? Since at each step I need the previous step. At each step I need the previous step. So can I say this previous I can store, because look, when I will calculate for dp of 3, this dp of 3 would be the previous for my dp of 4. For dp of 4, my dp of 3 would be previous. And we only need one stage, or like prior step at once. We don't need a dp of like maintaining from some 1 to n. We only need the prior step. So instead of making dp of an array or a vector or an array list, can I actually do by making it just as a pref variable? Because at the when I will be calculating dp of 4, I need dp of 3. Just I need to maintain a variable. So can I actually keep this as priv? And this would be my current. And the next time this would be my current, and this is my priv. And the next step after, because at the fourth iteration, my this priv for this is my current. Currently, I'm calculating dp of 3, and for dp of 3, the dp of 2 is priv. But when I would be at dp of 4, when I would be at dp of 4, this current would be my priv. This current would be my priv, because now I'm coming down. I use this priv for this step. So the current I calculated here, this would be priv for my next step. So I can, at the last step, I can say, okay, now update my priv as equivalent to current. So in this way, we don't need a DP array. So I hope I was able to explain you the intuition, how we reduce the formula, and what is our DP of I. This is the most important thing. This is the most important thing. DP of I is equals to sum of substrings till index I, whose last character is s of I. So now, how we will code this problem? Let's move to the editor. Here we have to do the code now. So it all breaks the flow. So yes, so let's take a const variable first, and because we have to take a modulo, so I have taken a const variable, and its value is 29 plus 7. Now let's take a variable int for size. And now I will say this is my actually my DP array, and let's take it as long. What I'm doing, n plus n find 0. Now, what would be our DP of 0? Like we have to define our DP of 0 first, because for DP of 0, we would be actually needing I plus I minus 1 state, and that don't exist. So for DP of 0, it would be S of 0 minus 0. And why? Because when I showed you here, the number of possibility fixing the last character, the first character, the 0th index at last was only 1, because 1 is first character and I can only fix it once, and the sum I will get is 1 only. So that's why my DP of 0 would be S of 0 minus 0, because there is only one way in which I can fix my first character as last character. And for further steps, I would be calculating my DP from I is equals to 1 to I less than n plus plus I. And now let's say long current. This would be, we have already discussed, this would be my current character minus, this will give my current character, into, this would be I plus 1 times, this would be I plus 1 times, okay? We have already discussed, like when I have to fix 2 at last, the number of ways in which I can fix 2 was I plus 1. Here it was only, here also it was I plus 1. We have I as 0. So 0 plus 1, only one way was possible. Here we have at index I, two ways are possible. When we are at index 2, 2 plus 1, three ways are possible. So I plus 1. And plus, we already know 10 into my previous state of DP. 10 into my previous state of DP. So this will give me current. Now, result would be the sum. So this is the sum of fixing the ith character at the end, and so I need to add into my sum, and I have to take the mod because I need to maintain that constraint so that it don't overflow. And since I calculated my current, this is my current state of DP that would be used by my further state, that I am using this for this stage, and this stage is calculating. Now at the next step, I would be using this step, like this DP would be using. So I have to update my DP of I as my current. So now I can return my result because result stores the updated value. And it has also calculated for the next step, but we don't need that because we need till the ith one. So let's run this. Hope I have not made any errors, or we will fix. So it says result. Okay, again. So like long result I have forgot, and it would be our DP of 0 because this is calculating from I equals to 1, and so DP of 0 is also the part of the answer. So DP of 0. And let's run this now. So we are getting 1670. And earlier I got some overflows while recording the video because I was not taking this long array like in the previous part when actually someone came and I have to stop. Again, we are getting that overflow because we didn't do this modulo. So this modulo is crucial. That's why all these things disturbs the flow. So like we are getting 1670. I have taken long DP of 0 is this. Current I have taken the modulo, result I have taken the modulo, and DP of I is my current. I have taken the modulo for current. So hopefully this will work fine. Yes, this is working fine. And from how many time I'm making attempt. So like here, this was that code, the brute force. Here also I got overflow, and then someone is disturbing. So like, okay. So why overflow? You have already seen that again while making the video, I got this penalty because I actually forgot to take the current one. Here also I forgot to take that step only. So this is the when we use a DP array. So actually we discuss at every step, I only need my previous step. I only need my previous step. So can I store this previous step with me in a variable instead of using this order of n DP array? Yes, we can do. So now long, like we don't need this. We actually don't need this. We will space optimize this, and this DP of 0 would be nothing but long priv, and previous value is nothing. For 0th is this. For result, I will kept my previous value. Previous value is this only. And here my dp of I minus 1 for the 1th step is dp of 0, and that is my previous holding. So I can actually say, okay, this is my priv. And when I was doing dp of I, next time the previous, that this I using this previous and calculating a current. This time my previous would be this current. So I can actually say, okay, next time the previous would be the value I am actually calculating. So previous is equals to current. We have removed our DP array, and let's run this because at each step we only need the prior step. 1670, we are getting 1670, and hopefully this works fine. So yes, we are getting all things are fine. Okay, yes. So all things are fine now. Overflows and runtimes cause penalties. And now we are practicing, but in contest they do suffer a lot, especially in lead code. Okay, so this, let's discuss the time complexity. So like coming from the very time limit code, this was actually n square because I'm iterating n times. So this is n square, and the space complexity for this is order of 1. For this approach, we are using a vector of dp for storing all the states. So it would be order of n for my time complexity and order of n also for my space complexity. Now, for this approach, we removed the dp array because at each step we only need a prior step. So now the time space complexity is turned to order of n. So time complexity is order of n, and space complexity is, we have removed, it's boiled down to constant. So this is the entire problem. I hope you get the intuition that how this formula has been deduced, and you can do the same dry run for these examples. And actually, that's all about the code. And thank you. And KNOCKCAT this side.